Let us solve a numerical on brute force attack for Caeser Cipher. Let us say we have to perform brute force attack on ciphertext LTI. Since it is an attack, the key is unknown. So the intention here is to find out the correct key. Okay. The attacker already knows the decryption algorithm. What is the decryption algorithm? The attacker tries to recover the plaintext using the ciphertext minus key mod 26. Now, ciphertext in this case is LTI. The key is a number which as of now the attacker does not know. But he knows that he is going to try all different numbers and try to find out which is the correct number. Now, as the decryption algorithm is working on numbers, we have to assign number to the ciphertext letters L, T and I, for which we require the mapping table. So, mapping table is a table where you assign numbers to each of the letters. A is assigned to 0, B is assigned to 1, C is assigned to 2, D is 3, E is 4, so on and so forth till Z is 25. So now, what is the number corresponding to L? It is 11. So my ciphertext numbers are, the number corresponding to L is 11. Then the number corresponding to T is 19. The number corresponding to I is 8. Therefore, the decryption algorithm will process the numbers 11, 19 and 8. So LTI corresponds to ciphertext numbers 11, 19 and 8. Let us now see how the attacker would perform a brute force attack. The given ciphertext is LTI. The ciphertext numbers for letters LTI can be found out from this mapping table. So L corresponds to number 11, T corresponds to 19 and I corresponds to 8. The attacker then assumes the key to be 1. So he has to subtract K and he has to do a mod 26 subtraction. So he deducts the key, that is K is equal to 1 from each of them. So you get 11 minus 1 is 10 mod 26, 19 minus 1 is 18 mod 26 and 8 minus 1 is 7 mod. So we have to do 10 mod 26 which is 10, 18 mod 26 which is 18 and 7 mod 26 which is 7. Now the attacker now will map these numbers to the corresponding letters using this mapping table. So number 10, as you can see, corresponds to K, number 18 corresponds to S and number 7 from this mapping table it corresponds to H. As you can see, the word KSH does not make any sense to the attacker and hence the attacker now moves to using the key KS2. So he again takes the ciphertext numbers, that is 11, 19 and 8, and he does a modular subtraction with the key, that is he subtracts minus 2 from each of these numbers, but he does this using mod 26 arithmetic. So 11 minus 2 is 9 mod 26, 19 minus 2 is 17 mod 26 and 8 minus 2 is 6 mod 26. Now 9 mod 26 is equal to 9, 17 mod 26 is equal to 17 and 6 mod 26 is equal to 6. The attacker now maps these numbers to its corresponding letters using the mapping table on the left. So the number corresponding to 9 is J, the number corresponding to 17 is R and the number corresponding to 6 is G. As you can see, the word JRG does not make any sense to the attacker and hence he moves to using the key K as 3. Now again he takes the ciphertext number, that is 11, 19 and 8, and he does a modular subtraction using the key 3, that is he subtracts minus 3 using mod 26 and the resultant is 11 minus 3 is 8 mod 26 which is 8, 19 minus 3 mod 26 is 16 mod 26 which is 16 and 8 minus 3 is 5 mod 26 which is 5. The attacker then maps these numbers to the letters. So 8 will be mapped to I, 16 will be mapped to Q and 5 will be mapped to letter F. This mapping is done using the table on the left. So now again you see that IQF does not make any sense. So the attacker now uses the key 4. He uses the ciphertext numbers, that is 11, 19 and 8. He deducts the key, that is he deducts minus 4 from each of these numbers, but the subtraction is doing mod 26. So 11 minus 4, 7 mod 26 is 7, 19 minus 4 is 15 mod 26, 15 mod 26 is 15 and 8 minus 4 is 4. Mod 26, 4 mod 26 is 4. Then he checks what are the letters corresponding to these numbers from the table on the left. So 7 corresponds to H, 15 corresponds to letter P, and 4 corresponds to letter E. The word HPE again does not make any sense, so the attacker moves on with the next key, that is 5. So he again takes the ciphertext letter 11, 19 and 8. He subtracts the key, that is 5, from each of the ciphertext numbers, but the subtraction is done using mod 26 arithmetic. So now 11 minus 5 is 6 mod 26, which is 6. 19 minus 5 is 14 mod 26, which is 14, and 18 minus 5 is 3 mod 26, which is 3. He then checks the letters corresponding to these decrypted numbers. So the letter corresponding to 6 is G, the letter corresponding to 14 is O, and the letter corresponding to number 3 is D. So the decrypted output is God, that is God, which makes a sense. So since he recovered a sensible word, the correct key is K is equal to 5. If he would not have recovered the correct word, he would have gone ahead to check key K is equal to 6, 7, 8, 9 and so on till key 25. So brute force attack is an attack where the attacker tried to attack the ciphertext LTI using decryption algorithm, that is P is equal to C minus K mod 26. In order to perform brute force attack, he used key K is equal to 1 and decrypt. The recovered plain text was KTH, which did not make any sense. So he moved ahead with the next key, that is K is equal to 2. He decrypted it as JRG, which again did not make any sensible word. So he moved on with key K is equal to 3. He recovered the plain text as IQF, which again did not make any sense. So he moved ahead with the next key K is equal to 4 and recovered the plain text as HPE, which again did not make any sense. Finally, when he used the key 5, he decrypted the ciphertext LTI as plain text God, that is God, which made sense, and hence the correct key is K is equal to 5 in this case. But if he was unsuccessful to decrypt here, he would have moved ahead with the next key, that is 6 and then 7, 8 as long as he reaches 25 in case of Caeser cipher to recover the correct key. So brute force attack is a type of attack where the attacker knows the decryption algorithm, he knows the ciphertext, he has to find out the key, and for which he does an exhaustive search using all the keys and try to find out which is the correct key. So I hope everyone understood the concept of brute force attack and how do we solve the numericals of brute force attack in case of Caeser cipher. So thank you everyone for watching the video. If you have understood the concept, I request you to kindly like, share, comment and subscribe. Take care, stay blessed.